Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, we are going to continue the region test of Algebra 1 for January 2025. We finished part 1 last time, so now we have 3 more parts, but they are shorter, or we'll see how long it's going to take. In problem 25, the first problem, and each correct answer will receive two credits. It says the graph below models Sally's drive to the store. So they show you the time and the speed. So of course, Sally started driving at 0 miles per hour, started to increase, and then increase more at more higher rate because the slope here is higher than that. And then do you see what happened here? State an interval when Sally is traveling at a constant speed. This is the speed, and the speed is at 35 miles per hour between the time 5 minutes and 9 minutes. So we say time is greater than or equal to 5, less than or equal to 9, and explain your reasoning inside this interval. We are not going to write everything, but you can say within this interval, the speed was constant at 35 miles per hour. Okay, so that's a very simple and easy question. Let's move to the second one. Graph the function f of x equals x squared plus 4x plus 3. Of course, this is a parabola since it has x squared, so you can solve. What's the meaning of solving when you draw just one graph? It is where the graph intersects the x-axis. So if you factor this, you can factor it as x plus 3 times x plus 1. Because these are two numbers that if you multiply them, you get positive 3, and if you add them, you get positive 4. Okay, and then you equate that to 0. Why do we equate it to 0? Because that's the y, or f of x, and you want the intersection of the graph with the x-axis. You say, okay, so my f of x should be at 0, this line, right? So either x equals negative 3 or x equals negative 1. And sure enough, if you have 2 points crossing, you know that a parabola is equidistant from a line called the symmetric, the line of symmetry. So the line of symmetry, which should be between negative 3 and 0 and negative 1 and 0. What's exactly in the middle? Yes, you said it, negative 2 and 0. So really, I should get this is, I'm going to draw it with a dashed line because it's not part of the graph, but it's the axis of symmetry. Oh my God, it's not going to. Why kiss? Okay, it doesn't matter. This is x equals negative 2. That's the axis of symmetry. Well, when x is negative 2, x squared would be positive 4. 4x would be 4 times negative 2, meaning negative 8 plus 3 equals negative 1. So negative 2 and negative 1 is a point on the graph. And then you see for a square, you move 1 to the right, 1 up, 2 to the right, 4 up. And you can see that the y-intercept is at 0 and 3. So that confirms, and because this is a line of symmetry, so a point on the right, 2 units from the axis of symmetry corresponds to a point here, and you try to join. They don't test you for accuracy, just points that you select are correct. So that's the second problem. The third problem. The function f of x is shown in the table below. State an appropriate value for m. Where's m? Oh, this. So that f of x remains a function. What do you know about a function? A function can have the same f of x for multiple x's, but cannot have multiple f of x for a single x. So I already used x equals 0, 1, 2, 3, 4, 5, 6. So if you pick any other value for m, positive or negative, integer or fractional, it doesn't matter. I can say the easiest thing since I reached 6, I say m equals 7. My reasoning is I couldn't use any x between 0 and 6 because if I did, that wouldn't. So for example, if I say this is 0, but 0 is 6, and here it says 0 equals 8, or is combined with f of x. So f of 0, is it 6 or 9? I don't know. So that's not like this. This is not a function. Well, this is a function, but if it were horizontal, I say, okay, what value corresponds to that? This or that? It doesn't work. So we say this is a relation. It would have been a relation, not a function. In order for it to be a function, if it's a graph, I apply the vertical test and see that the vertical line test, that the line doesn't intersect the function in more than one point. It may not intersect it at all, but if it does, it doesn't intersect in more than a point, just a single point. And that's my reason. If I pick any value between 0 and 6, that would become a relation, not a function. So that's the third problem. If we move to problem number 4, they tell you solve x squared plus 8x equals 33 by completing the square. Completing the square, and I went over that in other videos, is so easy. You combine the x squared and the 8x, and even if the 33 was on the left, you leave it outside. And then to complete the square, you divide the x coefficient by 2, it becomes 4. Then you square it, it becomes 16. And since you added 16 to the left-hand side, you have to add 16 to the right-hand side. The left-hand side, remember, when we divided the positive 8 by 2, we got positive 4. So that's x plus 4 squared. You don't need to worry. It's just that. Always the number that, so when you divide 8 by 2, you get 4. So you can write x plus 4 quantity squared, and then you square the 4 and write it here. Equals 33 plus 16 is 49. 49 is a perfect square. It's 7 square, right? So I would apply the square root of both sides. Notice this is a square, so I will have two answers. This is a point where many students forget to say equals plus or minus 7. Okay? So now you say either x plus 4 equals 7, and then you subtract 4 from both sides, so you get x equals 3. And then if you have time, you substitute 3 squared is 9, and 3 times 8 is 24. 24 plus 9 is 33, so you check your answer. You don't have to, but you could. Also, you could say, or x plus 4 equals negative 7. So you subtract 4 again from both sides. So you get x equals negative 11. And if you say negative 11, you can use your calculator. When you square negative 11, you get 121. And negative 11 times 8 is minus 88. So 11 minus 8 is 3. And this becomes 1. 11 minus 8 is 3. So you get 33. Again, you can check it out. You don't have to, but if you are a little worried, did I do it correctly? Very easily, you can check your answer. Question number 5. If f of x is that, algebraically determine the value of x when f of x equals negative 22. couldn't be any easier. So they tell you at this point, when you use f of x equals negative 22, they want the value of x. So since this is f of x and this is f of x, you say negative 3 minus 5, 3x minus 5 over 2 equals negative 22. Right? Because both of them are f of x, so they must be equal to each other. You multiply the left-hand side by 2 and the right-hand side by 2. So the 2 and the 2 cancel, and you get negative 3x minus 5 equals negative 44. Then you're going to add 5 to both sides, and you get negative 3x equals negative 39. And finally, you divide both sides by negative 3. These cancel. Negative by negative is positive. 39 over 3 is 13. So x equals positive 13. Right? So the second part so far is so easy. We have one more question. And it says, rationalize the denominator of the fraction and express the solution in simplest form. Of course, when you have an irrational value or number in the denominator, you multiply it by its conjugate. What's the conjugate of root 2? Is root 2. But if that was root 2, say plus 3, I would multiply top and bottom by root 2 minus 3. That is the conjugate. But since there is no constant term, there is no plus or minus something, it's just root 2. So I'm going to say root 2 over root 2. So the numerator becomes 4 root 2. The denominator is 2. Root 2 times root 2 is 2. Notice you can still simplify because 4 over 2 equals 2. So you get final answer is 2 root 2. That's the simplest form. And that concludes the second portion of the test. In part 3, you have 4 questions and each answer receives 4 credits. Okay. So you have to show your work, of course. Alex had $1.7 in nickels and dimes on his desk. There were 25 coins in all. Write a system of equations that could be used to determine both the number of nickels, N, and the number of dimes, D. Usually when we solve a problem like that, we say let N be the number of, but it's already given to you. So I have nickels and dimes without values, just a number. How many nickels, how many dimes? Altogether, they are 25. So that's a very easy equation. I can say nickels plus dimes equals 25. The second equation says they have a value of 170. So we can use cents easier. So we say, okay, each nickel is worth 5 cents. So if I have N of them, they are worth 5 times N. Every dime is 10 cents. So if I have D dimes, their value would be 10D. And the sum of these two, because these are in cents, 5 and 10, I have to write this in cents, 170. And then you can use your calculator, or I always prefer to use elimination. So I see a 1 and a 5, 1 and a 10, I can take either one. So for example, I can say, let me multiply the top equation, right and left, oops, by negative 5. Oh my God, I don't know why they make it such a way. It's not easy to take it off, I think. Times negative 5. And then I'm going to add the two equations together. So the top equation is negative 5n minus 5d equals negative 125. 5 times 25. And then I'm going to add them up. So these two cancel. 10 minus 5 is 5D. 170 minus 125 is 45. Then I divide by 5, and I get the number of dimes is 9. So I have 9 dimes. I can go and substitute in the first equation. N plus D, which is 9, equals 25. Subtracting 9 from both sides, it gives me D equals 16. Oh, I'm sorry, did I say N, not D? Why did I say D? N equals 16 nickels. And sure enough, you can multiply 16 by 5, you get 80. You know that if you multiply by 5, you just divide this by 2 and add a 0. So 16 over 2 is 8. You add a 0, so that's 80. Multiply 9 by 10, that's easy. Just add a 0. And 90 plus 85 is 107. 90 plus 80 is 170. Use your system. Yeah, we already, so this part comes here. So we write the two equations here, and then we solve at the bottom. I'm sorry, I just did everything. I thought they have something else to ask. The second problem, oh, that's statistics. They want the regression line. Okay, so they give you average heart rate and calories burned in an exercise or something, Olympic rowing team. And they want you to write the linear regression equation. You learn how to do that by going to stats. And you edit two lists. You make the X, for example, is the first list, 135, 147, 150, 144, 146, 153, 143. Make sure that you enter them correctly, because sometimes you hit a button and it doesn't write anything. So instead of say 143, you get 14. And you did the math, you know how to do it, but you missed some number. So you have always to look 725, 812, 866, 761, 825, 863, and 737 Boeing. Okay. Did you see 9 or something? Alrighty. So now you go back to stat and select calc, and you go to number 4, which is the linear regression AX plus B. So it gives you, oh, it didn't, I think because we have to do the diagnostics on, but anyway, it gives you the equation calories burned, or Y in this case, equals, A is, they wanted to nearest tenth, so 9.1 times the average heart rate. Notice this is an equation of a straight line, because that's why we call it a linear regression. Plus or minus, I'm sorry, negative or minus 527.6, since they wanted to the nearest tenth. So again, 9.2, so Y equals 9.1x minus 527.6. State the correlation coefficient. If it doesn't show you here, you can always go to stat and take the test. Which one? I thought I would see it here. Yeah, you can do the linear regression t-test. Don't worry about the word t. You'll learn about it later, but you click, it tells you, oh, do you have the X in L1? Yes. Y in L2? Yes. Forget about the rest. Just click calculate. And if you go down, again, it tells you the 9.11 for B. It doesn't give you the A because we are not testing the A. And R is 0.9. Again, to the nearest test, r tenth, r equals 0.9. State the correlation coefficient rounded to the nearest 10. State what the correlation coefficient suggests. Notice r is always greater and equal to -1, less than or equal to 1. So if it's very close to 0, we say there is no association between heart rate and calories burned. If it goes very higher or very low, so if it's negative, you say, oh, of course not here. If the heart rate increases, the calories burned decrease, and vice versa. But if it's closer to 1, it means both. If one increases, the other does. If one decreases, the other does. They follow each other, meaning it shows a strong, because 90% is strong association, positive association. Again, I don't want to lose your or waste your time between the heart rate, between X and Y, but you understand you have to write between the heart rate and the calories burned and Y. Okay, and that, yeah, we still have number 33. Using the quadratic formula, solve for this, express the solution in simplest form. We know that this A is 1, B is 4, C is -3. The equation is X equals -b, so -4 plus or minus the square root of b squared, which is 16, minus 4 times 1 is 4 times -3 is +12 over twice a. You can write the equation if you want. This would be -4 plus or minus square root of 28 over 2. We know that 28 equals 4 times 7. So the square root of 4 is 2. I can write this as plus or minus 2 square root of 7 over 2. And then divide top and bottom by 2 and get x equals -2 plus or minus √7. Okay? And that's the answer. We have one more, and to complete part 3, it says solve the following system of equations algebraically for x and y. We know that since this equals y and this equals y, it means they equal each other. So x squared minus 7x plus 12 equals 2x minus 6. So I'm going to move these here by subtracting twice x and adding 6 to both sides. So I get x squared minus 9x plus 18 equals 0. I need two numbers that multiply to positive 18, so they must be either both positive or both negative, and they add up to -9, so both are negative. I know that it's x minus something times x minus something. And sure enough, I know 18 can be 18 and times 1, that's 19, or 9 times 2, that's 11, or 6 times 3, that's 9, so definitely 6 and 3. Excuse me. So either x equals 6 or x equals 3. Now, notice, we want to solve the system for both values. If x equals 6, then it's easier to substitute in the second equation. Why do I use a square? So 2 times 6, then y equals 2 times 6 minus 6 equals 12 minus 6 equals 6. So the first point is 6 and 6. That's the first answer. What is the second answer? If x equals 3, then y equals 2 times 3 minus 6 equals 0. So the second point is 3 and 0. And you can put them between braces with a comma in between to show the set of solutions. But these are the two solutions. Again, if you have time, you can go back and check, but it's not worth it. Okay, part 4. It's only one question and it's worth 6 credits. Okay, so it didn't take that long. We can complete this. It says Anna plans to spend $30 on balloons and party hats. Oh, this is exactly like the nickels and dimes. Same idea. For her daughter's birthday party, including tax. So they are $30 altogether. We have balloons and hats. Including balloons cost $2 and party hats $1.50. The number of party hats Anna needs is twice as many. Okay, so here they didn't tell you the other one had like 25 coins. Here we said that the number. Okay, so let's first of all, if X represents the number of balloons and Y represents the number of party hats, write a system of equations that can be used to represent the situation. They didn't tell you to answer. So don't spend time doing that. But you can find the solution for your own part. So the number of hats is double. So the number of hats is Y. So Y equals 2X, right? The number of hats is twice as many as the number of balloons. Always remember so you don't confuse. Then it tells you if each balloon costs $2, there are X of them. So the cost of X balloons is $2X. And each party hat, which is the Y, cost 150. So 1.5 Y, all of that, when she spent all this money, that was $30. Okay? So now these are the two equations. You can say Y minus or 2X minus Y equals 0 if you want. And these would be the two equations, or these are the two equations. Alrighty, in the next page, what is the next page? The question is continued on the next page. Last page. Oh, graph your system of equations of the set of x's on the set of x's below. Okay, so remember the first equation was y equals twice x. Y equals twice x, meaning we don't have a y-intercept, right? There is no constant. So the line passes through the origin. And y is 2x. So the slope is 2, meaning every time you move 1 to the right, you go 2 up. 1 to the right, 2 up, and so on and so forth. So this is, of course, you cannot have a negative. So this would be like a ray, not a line, right? It doesn't extend below the 0. So, and we write on it, y equals 2x. Now, when you go back to the equation, second equation, it says 2x plus 1.5 y equals 30. So that's hard to draw. By the way, I showed you in one of the videos another form that for some reason I don't see it explained in classes. When you have an equation like that and the right-hand side is 30, divide the whole equation by 30. So that would be, I would have 1 on the right-hand side. If I divide 30, in fact, I should divide 2 by 15, so I get 1 over, 2 by 30, I get 1 over 15. So I'm going to write the 15 in the denominator. It's easier to say 13 divided by 2 is 15. That's what goes into the denominator. Plus 30 divided by 1.5. Notice that 30 divided by 15 Or 3 divided by 1.5 is 2. So 30 divided by that is 20. And this is the same equation. And you say, why do you make it fractional? It's so complicated. No. This is the x-intercept, and this is the y-intercept. So it's much easier. I can come here and say the x-intercept is 15, and I get the point right there. And the y-intercept is 20. It's here. I already have my line. It's much easier than to transform it into y equals mx and find the slope and find the y-intercept. And then, no, it's that easy. Okay. This was, well, if you want to write it again in y-intercept form, I'm going to subtract 2x from both sides. So I'm going to say 1.5y equals 2x, negative 2x plus 30. And then I'm going to divide the whole equation by 1.5. And I get y equals, this is 2, negative 2 over 1.5. Multiply top and bottom by 2, I get 4/3 x. And 30 over 1.5, we already said it's 20. You see the y-intercept is 20 as we found. And the slope is negative 4/3. Okay, so they want you to state the coordinates of the point of intersection on your line. The point of intersection is here. It seems like it's 5.5. I don't know for sure. It looks like 5.5 for the x and 11. I know that y equals twice x. So if I know that this is 11, that must be half of that. Explain what each coordinate means in the context of the problem. Well, each coordinate, this means theoretically, because you cannot have, then you have 5.5 balloons and 11 hats. How can you have 5.5 balloons? It doesn't make sense, right? So in real life, we will check the points. We call that, you don't have to worry about it, but we call that integer programming when we get problems like that. And we are going to look at the points inside here that are like I pick this point, that are integer, and then say, let me check 5 and 10 or 6 and 10 and see if I can, both of them can fit. So most likely I will get 6 balloons and 10, no, and 10 versus 5.5 and 11. But 6 and 10 doesn't satisfy the thing. So I can take 5 and 10. So they would be exactly double. So that's, I will still have money. I will not be using all $30. That's the trick here. But the coordinate, each coordinate, which 5.5 and 11, means the number of balloons and hats and party hats that you can buy with $30, the maximum number. And of course, 5.5 is not a number. So in this case, it would be only 5, right? You cannot have 5.5 balloons, as we said. So 5 and 11, but 5 and 11 doesn't satisfy this equation. It's less. So if you say, okay, if I have, I can have 5 and 10 or 5 and 11, but they don't want you to discuss that. They just explain what these numbers mean. And that concludes the test. They give you, they tell you to detach. That's a scrap and will not be stored. Okay, so that was the test. It really wasn't that hard. We didn't see any complications. They're everything in it you already learned. And if you are taking the test soon, or people in the future when they take this test, I wish them all the best. If you have any questions, please let me know. Otherwise, I hope to see you soon. Have a great day.